Okay. So cubic functions, all right, they also have a standard form, just like we did for quadratics. Okay, so if you remember, quadratic standard form was ax squared plus bx plus c, right? So for a cubic, it's ax cubed plus bx squared plus cx plus d, okay? A not equal to 0 there. And I didn't specify that back when we did quadratics, but I should have. Okay. So a few things, right? For quadratics, the A was with the x squared, the B was with the x, and the C was our constant term. But because we added in this x cubed term, we shifted all of our coefficients here. So A is always going to be like your lead coefficient, and then B will be the coefficient of the next highest degree term, and then C, and then D, and so on and so forth. Okay. Now, why is it important here? Why is it important here that we specify that the coefficient A cannot be 0? What would happen to our function if A was 0 here? What's that? It would fall apart? Yeah, it would fall apart. But why?
A needs to be the leading.
A would be the leading coefficient, okay, right? And wouldn't be what? I heard someone else say it. Haley? Yeah, it wouldn't be a cubic anymore, because if A was 0, it would be 0 times x cubed. That term would be gone. We would be down to a quadratic, okay? And so just because you have a 0 in front of your x cubed here, you know, that doesn't make this thing cubic. Well, just because that just goes away, it would be then bx squared plus cx plus c, it'd be a quadratic. So we need to specify that, okay? All right. Sometimes you'll see stuff, written down. It's important to ask questions about it too. If you're not sure about why this is, but you'll see stuff like this sometimes at the end, like, Mr. Wade, why is this here? Like this I get maybe, okay, why is that there? So feel free to ask those kind of questions if you ever come across something that's like, why did they put that here? What does this mean? What's it there for? Okay, so that is standard form, okay, of a cubic. Okay, and then you guys get probably a good idea about what a standard form will be for any polynomial, whatever degree. If it's a degree 4 polynomial, it'll be a x to the 4th, b x cubed, c x to the 3rd, or c x to the 2, and so on and so forth, right on down. All right, I guess, and eventually if you go past if you have a degree 26 or a degree 27 polynomial, you'll run out of letters, and I don't know what you start doing after that. But we'd be dealing with anything that high of a degree. So don't fret, okay? That would be too much. All right. All right, so we're going to graph now. What I would like you guys to do is to sketch the graph of f of x equals x cubed. Okay, now I'm going to recommend that we make a little chart here, like we have in the past. Okay, and we'll pick some easy-ish numbers there. I'm going to put 0 in the center. We'll put -1, -2 there, and then 1 and 2. Okay? And then go ahead, fill in the table, and then over here, let's sketch ourselves a little graph. Now, I'm going to go ahead and kind of spoil it a little bit for you. Okay? You're going to want to go higher and lower on your y-axis than you need to go on your x-axis. Okay, so let me see here if I can figure this out. I might count by 2s here, actually. That's what I'm going to do. So 8, 6, 4, 2, 0, 2, 4, 6, 8. Okay, so yeah, go ahead, sketch the graph of this thing. And you might need a calculator for it, but you might not, okay? Remember, we're just cubing this. I think you guys know how to cube stuff, right? What does it mean to cube something? Multiply it by itself 3 times, right? Okay. But if you need a calculator to do it, feel free. Go ahead. Let's fill that in now. Yeah. Okay, what's up?
So when I press the graph,
Okay, so you can see that your window, right, is like not in the standard viewing window. So if you press the zoom, you can go down to zoom 6. Oh, sorry, number 6. Sorry, zoom standard. There you go, and that'll fix it. Now, when you went to go press the window button, window that way too. You would just make sure your x min and y min would both be negative 10, and then your x max and y max would be positive 10. And you can fix it that way too. But Z standard does it for you.
Alright, thank you.
Yep, no problem. All right. I plan to. Oh, I was going to actually try to finish early-ish, so that way we can try to work on it in class. Is that okay? That way you don't miss it. Because I mean, I heard what you're saying. I think it could work, but let's see if it works this way. Hopefully. Okay. Okay. All right, so hopefully you got that for your table. Okay, if you didn't fill in the table, that's okay. You don't necessarily need it. Smudging. All right, and then we'll plot these points. So negative 2, negative 8, negative 2, negative 8. Okay, negative 1, negative 1. Oops, I got to be careful how I graph this here because I skip kind of by 2's there. 0, 0. 1, 1, so 1, and then I got to count up by 1's there. So, by the way, just a little note here, all right? On the x and y axis, you don't have to use the same scale, right? You don't have to use the same scale. So I counted by 1's for every block on the x-axis. I counted by 2's every block on the y-axis, right? So don't feel like you have to count by the same scale on the x and y there. Don't have to. And then 2, 8, right there. Okay? And then we'll just connect the dots. Okay, like so. Now, on our graphing calculators, all right, if we wanted to graph this, right, we would press the X, but there's no cube button over here, right? We have the square button, so we can square things, but there's no cube button. What button do we press to cube something? What do we have to press here? Yes, this little up arrow, little carrot looking thing, it's right above your division symbol. You press that, and you see that with I have like math print, so it like gives me like the actual exponent there. You're gonna just type in 3, okay? And that works, okay? If you don't have like the nice pretty print like mine does, it's gonna look something like this. Nope, it's not. It's gonna look like this, okay? Be careful with using this caret symbol because there's like not parentheses around it. I would suggest putting parentheses around your power there like that, just in case. I think it kind of like assumes it's just the first thing. I don't know. Maybe don't need parentheses for it, but anyway. It can be a little bit tricky there with typing that in. Back to math print though, because it looks so much nicer. X to the third, okay? Okay, and there's what the graphing calculator gives us. So like, yeah, that seems pretty good. Okay, that seems pretty good. Okay, if I really wanted to match this, I could go into my window and adjust things, right? Because from here, for my x min, I could put negative 3 and then positive 3. My x scale is counting by 1's. And for my y min and y max, I could actually do negative 8 and positive 8. And my y scale, I'm going to do 2 because I counted by 2's there. And if I do that, it looks even more kind of like what we graphed. Well, maybe. Maybe not so much. Anyway. All right. That's the idea, though. Okay. So, questions on any of that so far? All right. So let's analyze here what's going on. Let's analyze what's going on then, right? So we've got some classic function characteristics that we need to analyze here, like domain, okay? What is the domain? Negative infinity to infinity. Okay? So, just like quadratics, just like absolute value functions, the domain here is negative infinity to infinity. There's no x value. There's no x value that we need to restrict from there. Okay? What about the range here? What's the range? What's the lowest y value? Negative infinity. What's the highest y value? Infinity. That's right. Okay? So, different than quadratics and absolute values. Right? That's different. In quadratics, okay, for like x squared, for example, right, we didn't have a range that was negative infinity to infinity, right? It was either from negative infinity up to our vertex, or it was from our vertex up to positive infinity, right? Depending on the shape of the graph, right? If it was concave up, it would be vertex to positive infinity. If it was concave down, it'd be negative infinity to the vertex. Okay. But for cubics, the range is negative infinity to infinity. Okay. What about any zeros? Do we have a 0 here? Yeah. X equals 0. Or 0, 0, the point. Bless you. Okay. Okay, very good. Let's see what else we want to do. Okay. How about, is the function increasing at all? And if so, over what interval? No one feels so certain about this one? Where are we? Are we increasing at all? Yeah, okay. Where are we increasing? From what x value do we start increasing to what x value do we stop increasing? Okay, 0 to infinity. All right, are we all in agreement there? Starts increasing at 0 and then goes up as from -1 to infinity. Okay, so we're increasing from, because it's still kind of going up there from -1 and then goes to infinity. Okay, are we good with that? Starts at -1, increasing. And there's more than that. Where is it increasing? Negative infinity to infinity. This thing is increasing everywhere. This thing is everywhere increasing. But Mr. Widmeyer, this arrow is clearly pointing down, and that means decrease. Kind of, okay? Increasing, remember, you're going up from left to right, right? Left to right. So from left to right, we are everywhere going up. Everywhere going up. Okay, now, you might be able to make an argument to me, if you really wanted to, that at the instant of 0, this thing actually does flatten out for an instant, all right? So at the instant of 0, it's constant. But from the left, it's increasing. To the right, it's increasing. So we'll just say it increases through the whole thing. But you can make an argument that at 0, it would flatten out just for an instant, okay? But we say increasing everywhere still. Okay? So, all right, that's increasing. Where is it decreasing then? If it's increasing everywhere, where will it be decreasing? Nowhere. Nowhere. There isn't any. Okay? It's never decreasing. It might be if we transform it, right? But for right now, the basic function here, never decreasing. Okay? Let's see here. Is it even, odd, neither? Is it even? Okay, for even, we're looking to see if it's symmetric over what? The y-axis, the y-axis. For then odd, it's symmetric about the origin. Or in other words, it's rotationally symmetric about the origin. So is this odd? Yes, because we could rotate it 180 degrees and look exactly the same. So it is odd. And hey, look, its exponent is odd too. Okay. Now that won't always be the case, right? Just because it's cubic doesn't mean it will be odd. But in this case it is, because you can rotate it about the origin there. And it works. Shoot, I thought there was one more thing I wanted to say there. One more characteristic. Oh yeah, sure, we can talk about maximum and minimum. Yeah, okay, we can talk about that. So our range kind of clues us in there. So do we have maximums or minimums for this? Do we have maximums or minimums? So no, not really, right? Because they're negative infinity and positive infinity, right? It just keeps going down, it keeps going up. So there is no the highest point, there is no the lowest point. It's just, that's it. Okay, that's it. Okay. Could have sworn there was something else. Oh, well, maybe it'll come back to me. All right, so that's it. Okay, very good. That's the graph of x cubed, okay? So this is going to be our parent function that we will be transforming, okay, today. This is what we're going to be transforming. We're going to taking things, we're going to shift it left and right, shift it up and down, maybe do like a vertical stretch or shrink, okay? There is like a horizontal stretch or shrink, but we can actually take care of it using a vertical stretch or shrink, and so we're not going to worry about the horizontal one. We'll just focus on 3 main kind of transformations. Left, right, up, down, and then stretch or shrink vertically, okay? All right. Cool. So then let's get into that. So let's review then our different kinds of transformations. All right, so if we have f of x equals x cubed and we transform that, using, some different shifts and things, we can have g of x equals a times, okay? So this is for our transformations. Okay. All right, we'll just review that here then. So then a, what does a do when you have a number in front of your x minus h cubed here? What's that a going to do? A vertical stretch or shrink, right? Okay, very good. So if a is greater than 1, whoops, off the screen, there we go. If a is greater than 1, what does that result in? A vertical stretch. Or you could say a vertical dilation there if you want to, vertical stretch, okay? If a is between 0 and 1, right? 0 less than a less than 1. If a is between 0 and 1, that's going to be a vertical what? Shrink, yeah, vertical shrink. Okay, and again, very intuitive here, right? Hopefully that makes sense, right? If your number, a there, if your coefficient is bigger than 1, so let's say like 2, right, it makes sense. Oh, we're going to double, so it's going to stretch it twice as much, right? If a is between 0 and 1, it's like a fraction like 1/2, 1/3, 4/5, okay? Those will shrink it because it's, multiplying by a fraction, shrinks your value. Or multiplying by a fraction between 0 and 1 shrinks your value, okay? What about if a is less than 0? A does this too, right? There's another kind of thing that a can be in charge of. What does a less than 0 do? If you have a negative a value, what does that do? Reflection over the x-axis, right. Reflection over x-axis and a stretch or shrink. Okay? And again, it's the same kind of principle here. If it's like a negative a value between 0 and -1, then it's going to be a vertical. It's going to be a reflect and then a vertical shrink. And if it's a negative a value that's less than -1, so like -2, -3, -4, that'll be again a reflect and then a vertical stretch. Okay. All right. Cool. What does the minus h do? Or what does the h do? Sorry, what is that h going to do? If h is greater than 0. So if h is positive, so if you have a minus positive number here, what's that going to do? Shift things which way? To the right. Okay, right? If h is less than 0, so it will be minus a negative number, which is really then plus positive, right? So if h is negative, minus a negative number becomes plus positive there, or just plus h. It's going to be a shift left. Okay? And folks, I'm going to tell you, I told it to you in the past 2 units, I'm going to tell it to you in this unit, okay? And then for the next couple of units, right? We will be doing transformations every unit, okay? This is kind of how we're going to start out for pretty much every unit. We're going to talk about what our new function is, graph the parent function, and we're going to talk about these transformations. So again, the more comfortable you can get with these, the easier things will go for you, all right? And hopefully you're already remembering these, from before. All right, and then finally the k. If k is greater than 0, so it's going to be plus a positive number there, what's that k going to do? Shift things up. Okay, and if k is less than 0, it's of course going to shift down. Okay. Okay. Ooh. Questions on any of that? All right, pretty straightforward stuff, yeah? So, let's see here what we can come up with then. Let's try some. And I'm just going to jump right in to like a couple transformations at once. I'm not going to spend too much time on like, well, here's one just shifted right one, or here's one just shifted down one. We're going to combine them all together at once here. All right, so let's just do a couple examples. So we're going to graph and identify the transformation from f of x equals x cubed. Okay? So we're not only going to graph, but we also want to be able to identify, name the transformations from its parent function there, x cubed. Okay? So let's do this one here. 2 parentheses x minus 1 cubed minus 1. All right. So what kind of transformations do we see here? That 2 in the front there, what will it do? Vertical stretch by a factor of 2. So in other words, it's going to basically double. Okay. What's the minus 1 going to do? Right 1, and the minus 1 at the end? Down 1. Okay, very good. Exactly right. Okay. So we're going to graph this then. Okay, well, let me talk about this. So vertical stretch times 2. Can you wait through this example and then let you go, just to make sure you can get it right, okay? We'll go right 1 and then down 1. Okay. Alrighty. So I'm going to just use this whole space right here, and let's see. So let's see, 8, 6, 4, 2, and we'll say that's 0. Okay. And then -2, -4, -6, -8. So again, I'm going to count by 2s on my y-axis just because it makes it a little bit easier. If you want to count by 1s, that's up to you. I don't know if that'll fit. So that is the catch. Ugh. Smudgy pen. I never really understood people that were left-handed when they complain about smudging things, because I always smudge things and I'm right-handed. So I don't know. Maybe it's worse for left-handers, though. Sorry to you left-handers out there. Do we have any left-handers in here? Oh, CJ, yeah, you know the pain. My wife's left-handed, so she feels your pain. Like I said, I still make a mess. Look at this. This is crazy. All right, anyway. So let's take our graph. Now, again, you can do this in a couple different ways. Option 1 is you can just literally go put this in your graphing calculator, right? I mean, so if you guys, if you really need to, right, if you have to fall back on this, right, we can take our function here, type it in, 2 parentheses x minus 1 to the third, okay, minus 1. Make sure use parentheses in appropriate places and stuff like that. You can go to your table, and voila, there's some values for you, okay? You'll notice, though, the numbers aren't super easy, right? Okay, we get, there's only a few numbers here that are pretty easy to graph, and then we get to -17 and +15 and -55 and +53. So it gets kind of out of control pretty quick, right? Okay, so there is that to keep in mind, but you can graph at least a few points here and get that curve. All right, let me just regraph here. So I'm going to graph, let's see here. I'm going to graph x cubed, just so we can see the transformation in black, and then I'll graph the g of x, our transform function, in red, so we can kind of see them over top one another. You don't have to do both, but I'm just going to do both here, so that way we can appreciate the transformations and stuff. All right, so x cubed, I'll just use those old points that we talked about earlier. So we had -2, -8. We had -1, -1. We had 0, 0. We had 1, 1. And we had 2, 8. Okay? I'll try and just lightly draw this in here. Okay, so there's x cubed. Right there again. And then our answer is this transformation. So how can we transform this without having to again, you can always fall back on your graphing calculator, but let's also try and graph this without using our graphing calculator. Let's see what we can do. All right, so transform, and I don't know if I want to call this the vertex, but let's just call it the center point of our cubic here, right? Remember, that's what we would do with quadratics and absolute value functions. We would transform the vertex first and then worry about getting more points. That's what we're going to do here too. So there's our vertex, and we're going to transform it by shifting which ways again? right 1, and then, well, down 1, right? Because it's a -1 on the end there. So right 1, down 1. So there's our new vertex. Okay? We could do the same thing for this point here, right? We could go right 1, down 1. But the problem is we also have to stretch it by a factor of 2 here. So instead, let's think about it this way. We've shifted our vertex here, okay? And how are these 2 points related in the past? Well, to get from here to here, I could go up 1, right 2. But now I'm going to double. So instead of going up 1, not right 2, sorry, up 1, right 1 is what it was. Up 1, right 1. Instead of going up 1, since I have that 2 in front, and now I'm going to go up how much? Up 2. So I'm going to count up 1, 2, and then right 1, and that will be my new point. And then same thing for this point right here. To get to this from my vertex or center point here down to this point, I'm going to go left 1, down 1. Well, then instead, because I'm going to double that, I'm going to go left 1, now down 2 to right there. Okay? And if you don't believe me, you can look here at the table and you can see that at 2, okay, we get an x or y value of 1, which is where that point is, right? And then at 0, we get a y value of -3, 0, and then there's -3 between the -2 and -4 there, okay? So the calculator figures it out. I mean, does, proves us that we're right there, okay? Now the other ones, well, we won't be able to graph those. We're not going to be able to fit them, okay? They just won't fit because, let's see here. To get from here to here, I have to go up 2, 4, 6, 7. And so I have to go up 2 times 7. So I have to go up to 14, and that's just not going to fit. So this is the best we can do. So I'm just going to kind of like do something like this. Okay, so the most I can really fit on there is about 3 points. Okay, the most I can fit on there is about 3 points. The other ones just won't fit. I mean, you can see that at 3, for example, we would have to go all up to a 15, right? And then to go to to the -2 there, or sorry, to go to -1, it'd be -17. So it's like just too far down, too far up there for us. So that's the best we can do. Okay, but you can kind of see. I mean, you can definitely see the shift, right? You can kind of see the stretch a little bit too, right? You can kind of see it a little bit. Looks a little bit more like elongated, right there. Okay. Questions on any of that? All right, let's try another one there. Let's try another one here then. Let's do h of x equals -1/2 parentheses x minus 3 cubed. Oops, off the screen. There we go. Okay, -1/2 parentheses x minus 3 cubed. All right, so let's identify our transformations here. Okay, reflect over x-axis. Okay, what else though? Besides, so it's negative, right? That's the reflector of the x-axis. What's that 1/2 going to do? Vertical shrink by 1/2, right? By a factor of 1/2. Okay, what's the -3 going to do? Okay, right 3. Good. And then, do we have any vertical shift? Are we going to shift up or down at all? No, there's no number at the end there, so it's 0. You can assume it's 0. Okay. Okay. So again, just for this purpose, I'm going to go ahead and graph, my old x cubed, the original parent function x cubed, and then we'll graph this as well. So let me see if I can fit this on here. I'm going to try and do the same thing I did before here. So 8, 6, 4, 2, 0, -2, -4. Okay. All right, so again, and then let's see here. Okay, so gosh, 2, 8, -2, -8. Okay, so again, there's just plain old x cubed. There's plain old x cubed, parent function. All right, and again, I'm going to transform this vertex. So we're supposed to go right 3. So from here, count right 3, right? So 1, 2, 3. There's my new vertex, or center point, you can call it maybe. I don't know if it's called a vertex or not. I can check on that. Okay, check on that. Okay, my new point of symmetry, I think is what they call it. Yeah, in the book. Point of symmetry. Okay, so there's that. And then instead of going up 1, right 1, now I need to go which way? Instead of going up 1, right 1, since I have that 1/2 and it's a negative 1/2, I'm not going to go up, I'm going to go down. And instead of going down 1, we're going to go down a half. So down 1/2, so it's going to be like more like a quarter, right? So like right there. Okay? And then instead of going down 1, left 1, we'll go up 1, left 1. So it's like a negative slope here. So up 1/2, and then left 1. So something like that. Okay? But of course, if you want to here, you can still make your little table. Okay? You can put that new center point there. So the new center point there is at 3. So I'll put 3 in the center, and it's at 3, 0. Okay? Pick some points before it, pick some points after it. Okay? And then we'll just get the matching y values by plugging in there or using our graphing calculator to help us. So negative 0.5, x minus 3 to the third. Okay, I'm going to try and squeeze that over here maybe if I can fit it. Okay, there we go. Okay. And let's see here. At 1 we get 4. At 2 we get the 0.5. At 4 we get negative 0.5. And at 5 we get negative 4. Okay. And so there it is, yes. 3, 0. 2.5, 4, negative 0.5. 1 is 4. That's not too hard to graph right there. And then 5, which would be right here, would be negative 4, which is right there. Okay. Oops. I didn't want to go to that point there. Okay. So just like that. You don't need to go through that point. It should be more like that maybe. Okay. So there it is. And again, you can kind of see, right, you definitely see the reflection, and you can kind of see it's like smushed down a little bit, right? So it doesn't look quite as steep of a curve there. Okay. But there it is. All right, questions on any of that? All right. If there are no questions, then I want to do 2 more, and then we'll be done, okay? And we're going to do things in reverse, okay? And I didn't do a super great job of this with quadratics, so that's why I want to make sure I do it here with you. We're going to do it in reverse. I'm going to give us a graph, and I'm going to ask what kind of transformations we see, okay? And then also what would be the function, too, okay? So questions on any of those? Pretty straightforward stuff, right? Again, you can always just fall back on your graphing calculator and make a table if you need to, okay? Just like we did with quadratics. Okay. And let's talk about how to do these when you're given the graph. Okay. Let me do this one here. Okay, so let's see. So okay, so let's identify the transformations for from f of x equals x cubed, okay, and write the function. Okay. All right, let's see here. So, nope. So we'll start with something like this. I'm going negative 6 to 2 and negative 6 to 2 on the x and y axes here, just because of where our thing is going to be located. And I'll go ahead and plot some information here. So we have a point at negative 1, 1. We have a point at negative 2, negative 2. And we have a point at negative 3, negative 5. Okay? So, what kind of transformations do we see here? I know you're copying it down maybe still, but you can still identify that, right? What kind of transformations do we see here? Again, that's... How did our center point, how did our kind of like vertex or center point of our cubic, how did it move? Left 2, down 2, okay? So we went left 2, down 2, okay? So we know then for the function, this function here, we'll say g of x maybe is what this is, okay? And we know that we're going to have x cubed. So to shift left 2, what should I put in here with the x then? A plus 2, right, for left 2. And then what at the end for down 2? Minus 2, okay? Is that all that's happened here? Did it only shift left 2 and down 2? And a vertical stretch, right? How can we tell? Well, normally the next point from our vertex is right 1 and up 1 from it, right? Right 1 and up 1. But we can see here that's not the case, right? If I go right 1, up 1 here, I am not where I need to be. I have to go up, not right 1 and up 1. I have to go right 1 and up how much? 1, 2, 3 times as much. Okay? And normally I would go left 1, down 1, but in this case I have to go left 1 and down 1, 2, 3. Okay? 3 times as much. So then what number should go in front here? 3. Okay? So our A value there is 3. Okay? And then there's our H and K. Okay? There's our H and K. All right? If you remember, I showed you guys on the graphing calculator how you could get the graphing calculator to give you the function if you had some points. Let me show you how we can do that here. Same thing can be true here. Okay? So do you guys remember, what did we press on the graphing calculator to get it to give us an equation for like a quadratic? What did we press on it? Do you remember? When we wanted it to tell us the equation for a quadratic function, what did we press? What did we use? Press stat, okay, edit, all right, and you clear out your list 1 and list 2, okay, and then what goes in these lists? Well, just the points. So we can plug in, for example, negative 3, and then I'll put negative 5, it's matching y coordinate, and then I'll plug in negative 2, and negative 2, and I'll plug in negative 1, and whoops, not there. Oh, sorry, AJ. Yeah, you can go. I'm sorry for making you wait. Yeah, if you need to go to the bathroom. Sorry. All right, and then negative 1, 1. We'll plug that one in. Okay. And then what do we press? What should be next? Once you type them in, we can press what? We're going to press stat again, arrow over to calc. Okay. When we wanted a quadratic, we did quadrag. When we wanted a line, you could use linreg, but we want a cubic, so we should use cubic reg. All right, we'll go down to calculate there. Whoops. Something happened. I think I made an error. Negative 3, negative 5, negative 2, negative 2, negative 1, 1. This should work. L1, L2. Well, this is supposed to work. Now let me see. -3, -5. Yes. -2, -2. Yes. -1, 1. I am not sure why this isn't working. Let me try something else here. Let's see what let me try something else here. Let me put another point in. We'll do 0. Let's give it 8, 24, 22. Let's try this. Oh, okay. I think I just needed to give it another point. Okay, so it looks like for a cubic regression, and I think that makes sense to me actually. You'll need to have 4 points in there, okay? You'll need to have 4 points in there. So what I did is I just picked another x value of 0. I plugged 0 in here, so 0 plus 2 is 2, cubed is 8, times 3 is 24, and then minus 2 is going to give me 22. So I put in the point 0, 22, and then it allowed me to do it. So stat calc, cubic regression. Okay, and there you can see there's your A value of 3 that we get right there. Okay, and now this will give it to you in standard form, of course, but we want the transformation. We want the vertex or kind of vertex form there, I guess you want to call it. Okay, but that will give you your A if you're ever stuck on that. All right. Questions on any of that? I said we're going to do 2. Maybe we'll just do 1 here though, because I think we'll get the right idea. Okay. All right. So then, let me give you guys your assignment, all right? And then for those of you that are going to be finishing your test, we'll have you work on the test some more, and everyone else, you guys can work on this assignment from the book. Okay, and now... Okay, so for those of you that are done your tests, here's what I'm going to have you guys do for your assignment then. Yes?
I was about to ask. Can I go when you come back?
Yeah, and technically AJ's out, but go ahead, just go when you need. Go right now, and yeah, when
No,
Mike.
both of us to go?
Well, no, sorry, just one at a time if you don't mind, please. Thank you. All right, starting on page 178, which is in section 5-1. Okay. I'll have you numbers 2 through 4. Okay, and then 11 through 17, the odds there. Okay, and number 20 as well. Okay, there you go. All right, everybody else. I know some of you have to finish up your tests. Okay. Remember, you can access those books. I got books back there, okay, if you need them, or there's also your online book too.